Let us prove the identity in a triangle ABC. Sin A plus B by sin A minus B equal to C square by A square minus B square, where A, B, C are the side opposite to angle A, angle B, angle C respectively. For that purpose, let us start with left hand side. That's equal to sin A plus B divided by sin A minus B. Now we know the formula for sin A plus B, that's equal to sin A cos B plus cos A sin B. Again, sin A minus B equal to sin A cos B minus cos A sin B. So basically we need sine law and cosine law. So let's recall sine law and cosine law. By sine law we have A by sin A. So we have sine law that says A by sin A equal to B by sin B equal to C by sin C, and that's equal to 2r. So let's apply sine law first, then we will apply cosine law. So that implies sin A equal to A by 2r, and sin B is also equal to B by 2r. Therefore LHS equal to in place of sin A, I can write A by 2r. Instead of sin B, I can write B by 2r. So let me copy cos B as it is and cos A as it is. Similarly, in the denominator, let me copy cos B as it is and cos A as it is. Instead of sin A, let me write A by 2r. A by 2r. Instead of sin B, we can write B by 2r. The same is true in the denominator. Sin A, I can write A by 2r. Sin B, I can write B by 2r. Now we can take LCM and cancel 2r out. And so you will be left out with cos B plus cos A. 2r will get cancelled, so we have A cos B plus B cos A. What about the denominator? 2r will get cancelled, so you are left out with A cos B minus B cos A. You are left out with A cos B minus B cos A. Now let us recall the cosine law. By cosine law, cos A equal to B square plus C square minus A square by 2BC, and cos B equal to C square plus A square minus B square by 2CA. Therefore we can write LHS is A as it is. Instead of cos B, I can write C square plus A square minus B square by 2CA. Instead of cos A, I can write it as B square plus C square minus A square by 2BC. The value A remains copied, B also remains copied. The same is true for the denominator. Cos B is C square plus A square minus B square divided by 2BC. Cos A is c square plus a square, c square plus b square minus a square divided by 2bc. Once again, we have a and b as it is and the sign as it is. Now we can cancel a and a out. Similarly, here we can cancel b and b out. Oh, I made mistake here. Cos b is c square plus a square minus b square divided by 2ca. Cos b is cos a, yes, we have done it correctly. Cos a is c square plus b square minus a square divided by 2bc. Now we see that we can cancel a here as well, and we can cancel b here as well. And in the numerator, if we take LCM, we are left out with 2c. In the denominator also 2c. That also can be cancelled. So we have c square plus a square minus b square plus b square plus c square minus a square. Whole thing divided by denominator, we have c square plus a square minus b square minus c square minus b square plus a square. Let's cancel whatever we can cancel. We can cancel c square, we can cancel b square. So in numerator we are left out with 2c square. Oh, we can cancel a square as well. So we are just left out with 2c square plus 0. What about in the denominator? Denominator we are left out with 2a square minus 2b square. Well, we can cancel 2 as well once again. So we are just left out with c square by a square minus b square. That's your RHS, and we are done.